Today we discuss the first point in molecular spectrum, that is molecular bond. In that article we explain these points: how stable molecule is formed, the bond formation for stable system, and electron sharing in H2 plus molecule. Now firstly we explain how the stable molecule is formed. We know that when two or more atoms interact with each other, they form electrically neutral system. That neutral system we consider as a particle. Here we take one example of the H2 molecule. If the two atoms bond together, means they interact with each other, it forms a stable system, and total energy of that system gets reduces. Once the total energy reduces, the stable system require minimum energy. Hence the first requirement for the formation of the stable system is that it must have minimum energy. Suppose we say that if the H2 molecule break into the two separate atoms, it require some external energy to break H2 molecule into H and H plus H and H atom separately. That energy is dissociation energy. But when they interact with each other, the total energy reduces, the system becomes stable, and it requires minimum energy. Suppose if the total interaction energy between the two atoms or more than two atoms goes on increasing, then what happens? These atoms repel from each other. In that situation, the stable molecule cannot be formed. Hence, remember, once a stable system is formed by interacting two or more atoms or bound together, that system must possess minimum energy. Using that concept, if we suppose if the two or more atoms are brought together, then their different situations may be occur. And which are these situations? That situations are related to the bond formation. The first one is covalent bond. In that case, if the two atoms interact or bond together so as to form a system, that system possesses minimum energy. But when it is possible? If they share their electron between the two interacting atoms and a stable configuration is to be formed. Here we take example of the H2 molecule. H and H atom interact together. In that molecule, there are two electrons. These two electrons are orbiting electrons. They spend more time in between the two interacting atoms, and it produces the attractive force between these two. Hence, for the H2 molecule becomes a stable molecule, one of electron from each atom shared by the two atoms so as to form a stable system. Thus, the bonding formed between the two H atoms in H2 molecule is covalent bond, and that covalent bond is a result of sharing of electron between the two interacting atoms. Hence, under the covalent bond formation, it forms a stable molecule. Secondly, we explain about the ionic bond. Now, what happens in that case? the electron not share but they transfer from one atom to other atom. For example, sodium chloride. In that sodium having 11 electrons. One electron is extra to fulfill the outermost orbit. That extra electron transfer towards the chlorine. Since chlorine require one electron, total number of electron in chlorine 17. 17 plus 1, 18. That configuration gets completed. Hence, once the electron transfer from sodium to chlorine, we get Na plus and chlorine minus ions. And they interact. That interaction is due to ionic bond and it forms a stable system. But ionic bond formation does not give the result of the formation of independent molecule. But it forms a definite crystal structure. In that structure, the sodium plus and chlorine minus ions are arranged. Hence, remember, once the sodium and chlorine atom attract with each other, the bond exists only in between sodium plus and chlorine minus ions, but not between the sodium and chlorine atom. The next condition we say here, what is the next situation may occur once the two atoms are brought together. Suppose the two atoms combine together. When they combine together, the electronic structure gets overlap and it forms a single system. In that system, the Pauli exclusion principle is not applied. Why? Since every quantum state require only one electron, means no two electron can have the same quantum state. Then what happens? The one of the electron gets interacting electron gets occupied in the next higher energy state. It gets forced into the higher energy state. And once it gets into the higher energy state, the total energy of the total energy of the system becomes higher and it becomes unstable. In that situation, the bond formation cannot take place between these atoms, means molecule cannot be formed. Another example, HCl. It forms a stable molecule. H and chlorine interact together. It forms a stable system. But in that example, the electron sharing between these two atoms is not same. There is unequal sharing of electron. That is, the shared electron strongly attracted by chlorine minus ion than that of H plus ion. Hence, due to unequal sharing, again no bond formation can be takes place. Now see the next point. Once a stable molecule is formed by sharing of electron from one interacting atom to other interacting atom, how we explain? By using the another theory that we explaining here, electron sharing in H2 plus molecule. Now how that molecule is formed? One hydrogen atom and one H plus ion combined together. These two bound together and it form a stable molecule. That stable molecule is H2 plus molecule. But how is stable? That we explain here. In that H2 plus molecule, there are two protons and one electron. Here we draw the potential energy variation with separation between the two protons, R. We know that potential energy is inversely proportional to R, means R, as R increases, the potential energy goes on decreasing. Now, for first proton, we draw the two potential barriers around the proton A and around the proton B. Quantum classical mechanics, once we apply for that situation, then electron in the hydrogen atom cannot transfer towards its neighboring atom. But how the electron transfer, that we explain with the help of the quantum mechanics. Hence, quantum mechanically there is some probability, there is certain probability. That probability is that the electron can transfer from one potential barrier to other potential barrier. Means the tunneling effect can be takes place between the two potential barriers. The tunneling of electron from first potential barrier to other through the wall, since wall is in between the two potential barrier. Also, there is also the same probability for the transmission of electron back from the second potential barrier to first potential barrier. Such a to and fro tunneling motion of an electron is equivalent to the sharing of electron by the two protons. Now, when the probability of the tunneling goes on decreasing, probability of the tunneling decreases only when the separation between the two protons goes on increasing. Hence, step for formation of H2 plus stable molecule, there must be covalent bond formation between the two protons by sharing of electron between them, and the wave function should be overlap. The same concept we have to also explaining with the help of the Heisenberg's uncertainty principle. If the two protons are confined within the two potential barriers, then according to the Heisenberg's uncertainty principle, the electron possess the less momentum, means they have less energy. And if the electron has less energy, then the electron, once they share from one potential barrier to other potential barrier, during that process, the H2 plus system has less energy than that of two individual atoms, means H and H plus atom. Hence, we say here H2 plus is a stable system. For that one, total energy of H2 plus is always less than the total energy of individual free atoms. And that is possible only by the tunneling of electron from one potential barrier to other potential barrier, and that equivalent to sharing of electron between the two walls, between the two potential barriers with the wall between them. Hence, quantum mechanically, the probability of tunneling is possible. The tunneling from back to the original potential barrier is also possible. Hence, that process is equivalent to sharing of electron by the two proton. Hence, that theory also suggests, due to sharing of electron between the two potential barrier by these two proton, also form a stable molecule. Thank you.